Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. And make sure to stick until the end of the video where I have a bonus problem that is similar to this one, which you guys can try to solve. And I actually have two bonus problems for this video. So I have 9 to the power of x is equal to 18, and I want to find the value of x. So the first thing I'm going to do is I'm going to take the log on both sides. So now I have log 9 to the power of x is equal to log 18. And now, if I have something in the form log a to the power of b, I can actually move this exponent of b to the front of the logarithm. So this would equal b times log a. So now I have x times log 9 is equal to log 18. And now, I'm going to divide both sides by log 9. So then these two cancel out. And I'm left with x equals log 18 over log 9. Now log 18, this is the same thing as log 2 times 3 times 3. Log 9, this is the same thing as log 3 times 3. Now, I have x is equal to log 3 times 3 is the same thing as 3 squared, so I have 2 times 3 squared. Now 3 times 3 is the same thing as 3 squared, so I have log 3 squared. Now, if I have something in the form log a times b, this is the same thing as log a plus log b. So in this case, I have log 2 times 3 squared, so this is going to equal log 2 plus log 3 squared. I have this over log 3 squared. Now remember how I said if I have something in the form log a to the power of b, I can move this exponent of b to the front, and this would equal b times log a. So I'm going to do this with log 3 squared. I can move this to the front, so this would equal log 2 plus 2 log 3. And I'm going to do the same thing with the denominator, so I have over 2 log 3. Now this is the same thing as log 2 over 2 log 3 plus 2 log 3 over 2 log 3. And 2 log 3 over 2 log 3, that's simply equal to 1. So I have log 2 over 2 log 3 plus 1. Now, log 2, this is equal to 0.301. And log 3, this is equal to 0.4771. So now I have x is equal to 0.301 over 2 times 0.4771 plus 1. Now this is equal to 0.301 over 0.9542 plus 1. This is equal to x is equal to 0.3154 plus 1, which is equal to 1.3154. So this is our answer. The power of x equals 0. And I want to find the value of x. So first off, I'm going to take the log on both sides. So now I have log 2 to the power of x is equal to log 0. Now, if I have something in the form log a to the power of b, I can actually move this variable b, this exponent b, to the front of the logarithm. So this would equal b times log a. So in this case, I have log 2 to the power of x, and I can actually move this exponent x to the front. So this would equal x times log 2 is equal to log 0. Now, I can go ahead and divide both sides by log 2 because I want to isolate x. So then these two cancel out, and I'm left with x is equal to log 0 over log 2. Now, log 2, this is equal to 0.301, and log 0, this is actually undefined. So now I have undefined over 0.301. And this means that our answer is undefined, because you can't divide undefined over 0.301. Undefined is already undefined, meaning log 2 to the power of x equals 0 is undefined. And this actually makes sense because you can't take anything to the power of something and make it equal 0. So that is our answer. So I have 9 to the power of x is equal to 27. And this may seem like a challenging problem because if you notice, you take, let's say 9 to the power of 0, right? This is equal to 1. 9 to the power of 1, this is equal to 9. And 9 to the power of 2, this is equal to 81. Meaning, x in this case would be either a fraction or also a decimal, because it can't be a whole number. All right, so to solve this, it's actually really simple. 9, this is the same thing as 3 to the power of 2. So now if I replace 9 with 3 to the power of 2, I get 3 to the power of 2 to the power of x is equal to 27. Now, 27, this is equal to 3 to the power of 3. So 27, I'm going to replace with 3 to the power of 3. So now I have 3 to the power of 2 to the power of x is equal to 3 to the power of 3. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 3 to the power of 2 to the power of x, that's going to equal 3 to the power of 2 times x. It's equal to 3 to the power of 3. And 3 to the power of 2 times x, that's the same thing as 3 to the power of 2x. So equal to 3 to the power of 3. Now, if you notice, both of these have the same basis. Both of these bases are 3. And if I have something in the form a to the power of a is equal to b to the power of b, then this means that If I have something in the form a to the power of a is equal to a to the power of b, this means that if I have something in the form a to the power of c is equal to b to the power of m, this means that c is equal to m. So in this case, 2x is equal to 3. Now to solve this, simply divide both sides by 2. These two cancel out, and I'm left with x is equal to 3 over 2. Alright, so now to check, our original equation was 9 to the power of x is equal to 27. Now x is 3 over 2, so I have 9 to the power of 3 over 2 is equal to 27. Now, 9 again is the same thing as 3 squared, so I have 3 squared to the power of 3 over 2 is equal to 27. Now I have 3 to the power of 2 times 3 over 2 is equal to 27. These two cancel out, so I'm left with 3 to the power of 3 is equal to 27, and 3 to the power of 3 is 27. So if 27 is equal to 27, and because this is right, our solution is right as well. Alright, so in this video, I'm going to solve the problem 2 to the power of 30 minus 1. So to solve this, I'm going to rewrite this as 2 to the power of 15 times 2 minus 1. Now if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 15 times 2 is the same thing as 2 to the power of 15 to the power of 2. and negative 1 is the same thing as negative 1 squared. Now, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is 2 to the power 15, and b is 1. So now I have 2 to the power 15 plus 1 times 2 to the power 15 minus 1. Now, 2 to the power 15, well, what's the value of that? Well, 2 to the power of 10, this is 1024. So 2 to the power of 11 is double of 2 to the power of 10, which is double of 1024, which is 2048. So now 2 to the power of 12 is double of 2048, which is 4096. 2 to the power of 13 is double of 4096, which is 8192. 2 to the power of 14 is double of that, which is 16,384. And finally, 2 to the power of 15, this is double of this, which is 32,768. So I have 32,768 plus 1 times 32,768 minus 1. And now this is equal to 32,769 times 32,767. Now, a simple way to solve this, instead of having to actually multiply them the regular way, is to write this as 32,000 plus 769 times 32,000 plus 767. Now I'm going to distribute. So I get 32,000 times 32,000, which is equal to 1,024,000,000. This is 1,024,000,000. And now I have this plus 32,000 times 767. Plus 769. And finally, I have at the end 767 times 769, which is equal to 589,823. So let me add all of this up. You can actually do this on paper if you want, but just to make this easier, I'm gonna use a calculator to add all of this up. So if I add all of this up, I get 1,073,741,823. So this is my solution.